today we are going to be using zeros to write polynomials. We have spent a lot of time finding zeros from our polynomials, whether the zeros were imaginary or real or rational or irrational. And we've taken them and we've factored them and we've sketched them, but we're going to actually take some and write some equations today. This is going on page 48 when we are done. So there's some keywords I want you to focus in on the directions here. So it says write an equation that could represent the function with the given zeros. Here's what it does not say. It does not say write the equation that represents. So this write an equation that could represent is very important, because if you remember, our zeros will tell us where we intersect the x-axis. It will, even if we have multiplicity, tell us about some behavior on the axis, but we don't necessarily know just from the zeros, or we don't know just from the zeros, the maximum and minimum points. We don't know about some of the stretches and some of the other things. So we don't have enough information if we're just given the zeros to write the exact equation. I mean, we might get lucky, but there might be coefficients in there that we don't know about, right? So maybe that it got factored out or whatever. So we are writing an equation that could represent the function, okay? So with that said, here on this first one, we've got -2, -4/3, and 2. So we are going to write this down, working backwards, kind of like we did at the end of what we did yesterday. If we're given these zeros, that means that if I have -2 as the zero, that is x plus 2, right? Because this is we always have x minus c, right? So if x equals -2, then the factor is x plus 2, because it would make x plus 2 equals 0. Then this -4/3. I do not do x plus 4/3. Remember what we did with that. If I have x equals -4/3, then I'm not writing x plus 4/3 like this. I can look at this a couple of different ways. If I do end up with a fraction here, I'm just bringing that part up here because you're thinking about where this actually came from. To work backwards from here, I'd multiply both sides by 3, so 3x equals -4, so I get 3x plus 4. And that's what this would give me by bringing that up here. So this gives me 3x plus 4, and then I get, this would give me x minus 2. Okay, so again, I have no idea if there should be a negative sign out here that got factored out. Maybe there's a 5 out here that got factored out. Like, we don't know those things. So this is just something that could represent it given these zeros. Then we need to multiply this together. Like, I'm not just going to stop here. I can look at this and this makes that a difference of squares. So I'm going to multiply those two together, and when I do that, that's going to give me x squared minus 4 without too terribly much work. And then I still have to multiply this 3x plus 4 in there. Okay, and so then I multiply them. I'll do x squared by each one of these. So x squared times 3x is 3x cubed. X squared times 4x, x squared times 4 is plus 4x squared. Then -4 times 3x is going to give me -12x, and then -4 times 4 gives me a -16. Oh, but that's a 14. -16, right? So then I've multiplied all that out, and I don't have anything that I can combine, so that is it, and that is my answer. Okay. All right, let's look at number 2. So I have this plus or minus, plus or minus. Could have written this one as plus or minus, but it wasn't written that way. So to first write this out with my linear factors, means I'm going to have 4 of them there. I'm going to have x plus 2 square root of 3 times x minus 2 square root of 3 times x plus 1 times x minus 1. So what I have here is 2 sets of difference of squares. That's a difference of squares, and this is a difference of squares. Okay? So to multiply these two together, this is going to very easily be x squared minus 1, right? And then I got to look at what goes here. Well, this is going to be x squared minus something, right? what's going to be minus whatever 2 square root of 3 squared is. Got to know how to square that. So I want you to think about what it is. Now turn to your neighbor and tell them what 2 square root of 3 squared is. Now discuss at your table, what do you think it is? And if you don't all agree, somebody try and explain to the people at your table why you think you're right. I'm going to give you about 10 seconds for that. Okay, I think that was like 10 seconds. All right, so now let me explain to you which may be the same way you explained it to each other. I don't know, but when you square this, because there's no plus or minus sign in here, it's like 2 squared times the square root of 3 squared. I'm not saying you have to write that out, but that's what's happening. So you're going to get 4 times 3, so this is 12. Okay. So then I need to multiply these two together. So I will FOIL this one. First 2, x squared times x squared is x to the 4th. The outside 2 would give me negative 1x squared. Inside 2 gives me negative 12x squared, so it's negative 13x squared, and then plus 12. That is my possible function there. Now, those of you that like to work ahead of me because you think there's like some prize at the end for being the first one done, there isn't, so don't do it. And then, or if you like to work ahead because you think I have nothing of value to actually say to you, I wouldn't suggest doing that on these notes because you will most likely regret it at some point. All right, so let's look at number 3. I've got f of x equals, so to write this down, this is a negative 6, so this would be x plus 6, because it's really x minus a negative, right? Now, when I substitute these two in, right, this is 2 terms. This is actually 2 plus the square root of 5 and 2 minus the square root of 5. Any time you substitute something in with more than one term, it needs to be in parentheses. So, I'm going to have x minus 2 plus the square root of 5. And then x minus 2 minus the square root of 5. Okay, see how that works? Now, when I work with this, oh, I just realized this doesn't look like it's a minus. That's actually x minus the square root of 5. It looked like it was all together. This is not a difference of squares. Yes, there's a minus here and a plus here, but these would have to be opposite in order for them to work. And these would have to be exactly the same, which they are not. So I'm going to start by multiplying these two together because that's going to be way better than trying to multiply this one and then multiply that other thing in. So this x plus 6, he's just going to hang out here at the front. Okay? And actually, I would suggest so that we have plenty of room here, we're going to move it over. X plus 6. All right. And then we're going to multiply. So I'm going to start by multiplying x times each one of these. So x times x is x squared. X times a negative 2 minus square root of 5 is going to be negative x times 2 minus the square root of 5. So I've multiplied x times both of these terms. Now I'm going to multiply this by both of these terms. So when I multiply negative 2 plus the square root of 5 times x, it's going to give me negative x times 2 plus the square root of 5. Then I'm going to multiply this times this. So when it's a negative times a negative, that's actually going to be a positive. And then it's going to be 2 plus the square root of 5 times 2 minus the square root of 5. Okay. So take a second, look that over, make sure you understand where everything came from. You cannot drop parentheses here. You cannot be sloppy. You will not be able to keep up with your own work. I would also suggest we are not skipping a bunch of steps. You will get lost in all of this. All right. So now what I'm going to do, this guy here, he's still hanging out here. Now I'm going to basically distribute this stuff into here. Distribute the x into this and distribute this into this and so forth. So I still have this x squared. Then this is going to give me negative 2x plus x times the square root of 5. That's just distributing this x into there. Then I'm going to distribute this x into here. So it's going to give me negative 2x minus x times the square root of 5. So I've distributed that into both of these. Now when I look at this is two terms. This is a difference of squares. This is like x plus a times x minus a. And when you multiply those together, you just get x squared minus a squared, right? So what this is going to give me is I square the first one, plus 2 squared is 4, minus the square root of 5 squared. Square root of 5 squared is 5. Okay. So now I'm going to keep going here. And this equals, got x plus 6. Now let's see what we can do with this stuff in here. I got an x squared. It's the only x squared I've got. Then I've got minus 2x and minus 2x, which is minus 4x. Then I have positive x times the square root of 5, negative x times the square root of 5. Those zero out. And then plus 4 minus 5 is going to be minus 1. So I'm down to that. Okay, it just took some yucky stuff to get through it to get to that point. Now I'm going to distribute this x into each one of these terms. It's going to give me x cubed minus 4x squared minus x. Then I'm going to distribute 6 into all three of these. Plus 6x squared minus 24x minus 6. All right, so I've distributed all that stuff out. Now I'm just going to simplify it. I'll get my final answer here. There's only one of these x cubes. So I got that one taken care of. Negative 4x squared and positive 6x squared. That's going to give me a positive 2x squared. And I'm marking them out so that I keep up with what I'm doing. Got negative x and negative 24x is going to give me negative 25x. And then minus 6. And that is my answer. If you have sloppy, all over the place work, you are going to struggle with this. Okay? This is square roots. I mean, this is basically Algebra 1 skills, being able to multiply these polynomials. There isn't anything, the pre-cal part of this is knowing that, understanding how these are zeros and how we are writing the polynomial. Every single skill that it takes to get through the work is Algebra 1. Okay, so you cannot make excuses about, hey, this is so hard and it's pre-cal. Well, those are all Algebra 1 skills that you have to be able to keep up with your own work in there. All right, now let's see what happens with multiplicity. Right? So I've got these three zeros. This one has a multiplicity of 2. So let's think about what that means. Let's first write them in here. F of x equals, well, if one of them is 0, that's like x minus 0, which is just x. Then we have 1, which is going to be x minus 1. The 5 halves is really going to give us 2x minus 5. Right? But then we have a multiplicity of 2. Boom, there's our multiplicity of 2. That makes it a double 0 or a double root. Remember how we talked about that yesterday. All right, so now I'm going to distribute this, and then I will square this. So x times x is x squared minus x. And then I'm going to have to multiply this by this right here. This is a perfect square trinomial, right? So understanding the rule for a perfect square trinomial, which we've talked about a couple of times, is way better than actually foiling that stuff out. You start by squaring the first term, so this is 4x squared. You multiply these two together and double them, so this is 2x times negative 5 is going to be negative 10, but I double it, so that gives me negative 20x. And then I square this last term, which is a positive 25. Okay, way better than foiling it. But you got to know your special cases, and they're in that factoring flow chart that I don't remember what page it is off the top of my head, but it's in your ISN. I gave it to you like the first week of school, I think. All right, so now I have to distribute this. So I'm going to take x squared, multiply by each one of these. This is going to give me 4x to the 4th minus 20x cubed plus 25x squared. Then x times all of these is going to give me negative 4x cubed plus 20x squared minus 25x. Okay, so now I'm going to combine all my terms together, or all my like terms rather. There's only 1/4 term, so this is 4x to the 4th I've got two cubic terms, but this is a negative 20 and a negative 20 and a negative 4. So negative 24x cubed. I almost canceled it out with that. That wouldn't have made any sense. X squared, 25 and 20, plus 45x squared, and then minus 25x. That is my possible function. Okay. All right, and to not have a constant term should make sense, because if I was going to work the opposite way, then I would have to factor out an x, and that's where that comes from, and then I would go from there. All right, let's flip this over. So I have negative 1 that has a multiplicity of 3, and then I have a 5/4. So that means here I get f of x is equal to, is going to be x plus 1 times 4x minus 5. The multiplicity of 3 goes here. So the best thing to do here is kind of split up that cubed. I would make this into x plus 1 squared times x plus 1. That's the same thing as x plus 1 cubed. Then 4x minus 5. Okay. So then I would do this in pieces. I would go ahead and take this and square it. So perfect square trinomial, I square it, multiply these together and double it, square this one. Then I'm going to multiply, so that came from here, then I'm going to multiply these two together. So when I FOIL that, this is going to give me 4x squared. Outside is going to give me negative 5x, and inside positive 4x, so that's going to give me a negative x, and then minus 5. So then I've got to multiply these two trinomials together. The more consistent you are in how you do this and the more deliberate in your process, the easier all of this stuff becomes. So I'm going to start with this first one, x squared, and multiply it by each one of these. So this is going to give me 4x to the 4th, then negative x cubed minus 5x squared. Then I'm going to take the second term and multiply by each one of these. So that'll give me a positive 8x cubed minus 2x squared minus 10x. Then I take the 1 and multiply by each one of these, and I'm going to get negative 4x squared minus x minus 5. Now I have all of those terms, and I'm going to combine them all together. X to the 4th. I've only got one of those, so this is 4x to the 4th. Cubed, I've got this one. There's only two of them, so that's going to be plus 7x cubed. Got those taken care of. My squareds, I have 1, 2, 3 squared, so this is going to give me negative 7x squared plus 4 is going to give me negative 3x squared. And then I have that negative 10x and negative x is going to give me negative 11x, and then minus 5. So I end up with 1, 2, 3, 4, 5 terms there. This is my function. This, by the way, I meant to say this up here. This does not equal, so x plus 1 cubed does not equal x cubed plus 1. You don't just get to distribute the cubed. Not how that works. All right, so that's taking all of those pieces and putting them together with rational and irrational. So let's talk about the conjugate root theorem with complex zeros. Remember, they're all complex zeros, but really this should be imaginary zeros. So if a polynomial function has a complex zero at a plus bi, meaning that it's really written like a complex number, and because of that, b cannot equal 0, then its conjugate, okay, conjugate is something we did in Algebra 2. So if I have a plus bi, its conjugate is a minus bi, is also a complex zero. So I don't have to list it out. You just know that if you have an imaginary number, its conjugate is also one of the zeros. So when I look at number 6, I've got plus or minus square root of 6, and then I have 2i. So that's like a would be 0, right? I have 2i, which means negative 2i also has to be a 0. Because this 0 plus 2i, the conjugate would be 0 minus 2i. Okay, so we have to add that one in there. So when we write this out then, we get f of x is equal to x plus the square root of 6 times x minus the square root of 6 times x minus 2i times x plus 2i. So the nice thing here is that when I multiply these, this is a difference of squares, and these two are a difference of squares. So what this gives me is x squared plus, or minus the square root of 6 squared. And this gives me x squared minus 2i quantity squared. So think about what that is. Well, the square root of 6 squared is 6. So I get x squared minus 6. And then 2i squared. Let's think about this. We're going to kind of go off here over to the side. This x squared minus I squared. So x squared minus, well, 2 squared is 4. I squared is negative 1. So it's really x squared plus 4. That's what this becomes. Then we're going to multiply those two together. So if I FOIL this, the first 2 is going to give me x to the 4th. The outside 2 gives me 4x squared. Inside 2 gives me negative 6x squared. So that's negative 2x squared and minus 24. That is your function. Okay. Last one. Last example anyway. We've got negative 4 and 3 plus I. So negative 4, that doesn't mean positive 4 is also a 0 because it has to be an imaginary root to get your conjugate on there because b can't be 0. But if I have 3 plus I, then 3 minus I is also a 0. So I get f of x equals x plus 4 times x minus, and in parentheses, 3 plus I, and then times x minus, in parentheses, 3 minus I. Anytime you substitute in something with more than one term, you have to put it in parentheses. All right, so just like we did on the other one, we're going to go ahead and multiply. I'm not distributing that negative sign at this point. That just makes everything way more difficult. I want to look at this as 2 terms and 2 terms. I don't want to look at it as 3 terms. So this guy here, he's just going to hang out, this x plus 4. Then I'm going to multiply x times each one of these. This is going to give me x times x is x squared. X times a negative 3 minus I is going to be negative x times 3 minus I. Then I'm going to multiply this by both of these, so this will give me a negative x times 3 plus I. And then this times this is going to be a positive 3 plus I times 3 minus I. So I've distributed all that, or I've multiplied these, I've distributed. So now I'm going to distribute these things in here and clean this up. This guy is still hanging out here. So then this is going to give me x squared. When I distribute these, I get negative 3x plus ix. Then I distribute these and I get negative 3x minus ix. Then these are these two difference of squares again. So I square the first one, plus 9 minus I squared. And that's a t, dang it. I was doing so well too. I squared, okay, and I squared equals what? Negative 1, right? So this is really going to be 9. Think about what this means. This is really 9 minus a negative 1. That's what's happening right there with that I squared. All right, so then I still have this x plus 4. I'm going to clean this up some. The only x squared I have is this x squared. Then I have negative 3x and negative 3x. That's going to give me negative 6x. I have ix and negative ix. Those cancel out. And then this 9 minus I squared is really 9 minus a negative 1, which really gives me a positive 10. So now I'm here. Looks better. I got all the i's and stuff are not in there anymore. And then I'm going to distribute. So x times each one of these is going to give me x cubed minus 6x squared plus 10x. Then plus 4x squared minus 24x plus 40. So then f of x is equal to, I get x cubed, and then negative 6x squared and positive 4x squared, negative 2x squared. Then we get negative 14x with these two, plus 40. Okay, and that is it. The setting up part of it is the pre-cal part of it. The distribution, the multiplying, the keeping your signs straight, the understanding all of the other stuff, that is all Algebra 1 skills. The only thing that slips in that's Algebra 2 is an I. But then when you're multiplying that and keeping up with that, that is all algebra skills. And you have to have, it's not about having neat handwriting, it's about having organized work that, I mean, I don't have the neatest handwriting in the world, but I can organize my work. It's about having organized work, not necessarily, picture perfect work. All right? And that's it.